Hello everyone, you are watching another episode of Military Advance.
Some aircraft carriers use catapults to help accelerate airplanes for them to take off easier. Current carriers are using high-pressure steam catapults, which work a bit like giant springs, suddenly released to throw airplanes into flight. More modern approaches are electromagnetic catapults that are currently being developed. Either way, did you know that a catapult alone is enough to propel an airplane into flight? Catapults have launched aircraft from the decks of carriers for more than 100 years, solving the short runway problem. Planes taking off from modern carriers are limited to about 300 feet or less of runway, about an eighth of what they would normally need on land. Catapults provide a sudden burst of acceleration that can take a plane from zero to a takeoff speed of 170 miles an hour in just 2 seconds. Modern nuclear-powered carriers use steam catapults, diverting steam from the nuclear-powered turbines to the catapult system. The catapult system manipulates steam pressure levels and, once high enough, uses the force of steam release to launch airplanes into the air. Airplanes are flying because of the lift generated by the wings and, sometimes, body. When the airflow around the wings is sufficient, the difference in pressure below and above wings becomes lift and the aircraft takes off. That airflow is generated by an airplane moving forward on a runway or, in this case, on the flight deck of the aircraft carrier. Some aircraft carriers don't have catapults. Instead, airplanes accelerate by themselves and use ski jumps to gain some altitude. However, more advanced aircraft carriers are using catapult systems, which are so powerful they can generate enough speed for the aircraft to take off. Of course, airplanes ready to take off have their engines running and powered up. Even though catapult by itself is enough to generate enough speed for takeoff, to continue flying airplanes need their engines. If they malfunctioned or were not running for some reason, a jet fighter would be flying like a paper plane, just as far as catapult's energy would carry it. And catapults are very powerful. The steam method is tried and true, although it does require a lot of maintenance, and steam is dangerous to work around. Also, steam catapults are less flexible and it comes to launching planes of different weights, particularly small drones. An electromagnetic catapult can launch every 45 seconds. Each 3-second launch can consume as much as 100 million watts of electricity, about as much as a small town uses in the same amount of time. A utility does that using an acre of equipment, says lab engineer Mike Doyle, but due to shipboard space limitations, we have to take that and fit it into a shoebox. In shipboard generators developed for electromagnetic catapults, electrical power is stored kinetically in rotors spinning at 6,400 RPM. When a launch order is given, power is pulled from the generators in 2 to 3 second pulses, like a burst of air being let out of a balloon. As power is drawn off, the generators slow down and the amount of electricity they produce steadily drops. But in the remaining 42 seconds between launches, the rotors spin back up to capacity, readying themselves to release another burst of energy. If a plane is not on target for landing, the landing signal officer, LSO, can use radio or light signals to redirect the plane. The LSO can request that the plane abort a landing attempt. Pilots are also directed to the flight deck by the Fresnel Lens Optical Landing System, FLOLS. FLOLS is a collection of lenses that produces light beams at different angles. The different light beams inform the pilot about his or her position relative to the aircraft. In particular, if the pilot sees an amber light in line with a series of green lights, then the plane is correctly aligned with the runway. However, if the amber light appears to be out of line with the other lights, then the plane is misaligned with the runway. If the plane doesn't catch one of the arresting wires upon landing, then the plane takes off again from the ship. As a safeguard, when the plane lands, it immediately turns its engines to full power. If the plane successfully catches the arresting wire and comes to a stop, it is moved to the side of the landing strip. While accidents involving aircraft carriers are rare, crew members can be thrown overboard by a jet engine or be injured by onboard mechanical failures. In 1995, a sailor was killed on a U.S. aircraft carrier during a maintenance procedure. The crew member was maintaining the hydraulic system for one of the arresting wires, and one of the piston caps flew out at him. To help prevent injury during landing, aircraft carriers are equipped with fire trucks and tanks of water. Crew members also wear inflatable coats in case they are thrown overboard. The jackets have lights on them for search and rescue.